please welcome Andrew to the stage.
Thank you, Perry. Okay, so hi, I'm Andrew. For those who don't know me, I do developer relations for Fastly, and tonight I want to talk about clearing cache in the browser, which is something that I did some research into for the Perf calendar blog at the end of last year, and it turned out to be a lot more complicated than I thought it was when I started. I initially thought it would take me about an hour, actually, and it turned out to take me about a week. But it did produce a really interesting piece of research. So at Fastly, we like to talk about event-driven content. What we mean by that is content which doesn't change very much, but when it does change, you want everyone to see the update immediately. And another property of this kind of content is that quite often the change that's happened will affect multiple pages, and those changes need to be in sync. So for example, you have a home page with some stories on it, and those stories have a comment count against them. And then when somebody posts a comment on one of your articles, you want the comment count on the home page to reflect the number of comments you see when you click through to the article. So you need to update both of those pages at the same time. Now, traditionally, CDN caches find that quite difficult, and in fact, browser caches too, because content is cached until it expires, and it's unlikely that your homepage and your article page were cached at the same time. So even if they have the same TTL, this is quite a difficult thing to manage to synchronize. So for quite some time, Fastly has offered this thing where we can purge content proactively. You can send purge requests to the edge, and we can delete the items when they change, so that the next request will go to your origin server. But the problem with this is that you still can't really cache the content in the browser, because whenever the browser needs to visit that resource or that page again, it has to at least do a revalidation with the CDN to check whether that content has changed. And so in practice, you find that using this pattern, you're happy to allow the cache that you can control, the CDN cache, to hold on to the content for a really long time, but you can't afford to give that same privilege to the browser. You need the browser to keep checking whether the content has changed. So what we'd really like to do is something more like this, where you can purge all the caches that are holding onto this content, both edge caches and also browser caches. And if you could do this, then you would be able to cache the content for a long time in the browser as well as at the edge, in the knowledge that when it changes, you can purge it everywhere at the same time. So how do we do this? Well, we need two things. We need to be able to programmatically evict an object from the browser cache. So we're looking for some kind of API that is kind of http cache.delete with a URL. That doesn't exist, which is why this talk is not 5 minutes long. And, and the second thing is we need to be able to proactively push a signal to a browser that may not currently have a website open to say that something has changed and that the cache needs to be refreshed. So this one is more interesting because there are lots of hacks to try and get around the fact that this API doesn't exist, and I'm going to go through some of them now. So first of all, can I see a show of hands of who has attempted to solve this problem of evicting an object from browser cache programmatically? Okay, great. Keep your hands up, please, and keep your hands up if you attempted. Oh, I'm going to skip ahead. If you attempted to use this to do it. Oh, interesting. Okay, so this is actually the most popular technique I discovered in the wild for trying to evict an object from browser cache, and we'll see which techniques you are using later. But I also want to mention these other use cases which I found for this. So in addition to this event-driven content scenario, which I think is the most exciting use for this, we also have things like third-party scripts that want to ship updates, and it would be good if they could do that whilst maintaining a very long TTL, so that their customers are not having to continually request the script, and also recovering from mistakes and bad deployments. And I've certainly many times in my career shipped a front-end asset with a very long cache time, and months later had customers complaining that the site doesn't work, and you know that all they've got to do is clear their cache. So what would be really good is if you could just do that for them. So the first technique that I looked at was location reload with a true parameter. And this is because the parameter is a forced reload. This is documented by MDN as something which forces the browser to perform a reload of the document without consulting the cache, which sounds perfect. This technique was first promoted, I suppose, or popularized by Steve Souders in 2012. And it was actually a breakfast meeting with Steve that prompted me to do this research in the first place. He was very intensely insistent that I do it, actually. I think he was, he needed it done and didn't have time to do it himself. But it was great fun to do it anyway, so I was happy to do that. So he started to use this for SpeedCurve to update their Lux RUM client library when he needed to roll out updates. And in principle, all you've got to do is call location reload. But it's not quite that simple, is it? Because if you just did that, then you'd reload the page that the end user is looking at, and they would see that happen. So that would be a really unpleasant user experience. So in practice, what tends to happen is that you create an iframe, and then in the iframe, you load some kind of document, a kind of sacrificial document that is then going to create a sub-resource load for the thing that you want to clear from the cache, and then you call location reload on that. So the kind of document that the server would serve into that iframe would look something like this. It has a single sub-resource, and then it has a script which says, if we haven't reloaded yet, then reload. And this is a fairly ugly pattern. It requires loading the force reload page twice, and it also involves loading the resource twice, once from the cache and then once from the network. It also creates a browser history entry, and in very early versions of Firefox, it can go into a reload loop. So it's not great, really. So I thought, well, there must be a better way of doing this. But I first of all started by creating a test harness so that I could see whether these techniques actually worked in different browsers. And in doing this, I looked at the spec and I realized that the reload method, as defined on the location interface, doesn't actually have a force reload property. So whilst it's documented and whilst everybody seems to be using it, it's not actually specified. So what does it do? Well, not very much, as it turns out. I tried with and without the property, and there is a difference, but it's very, very minor. Chrome, it turns out, doesn't actually go to the network regardless of whether you pass force reload or not. Firefox is the only one to actually distinguish between the two, and it only makes a difference if the resource has cache control immutable. So it's a very narrow range of situations in which actually setting force reload makes any difference at all. The Chrome behavior, incidentally, is something that's changed relatively recently, and I think probably 15 or 20 versions ago, because when Steve did his original research, this technique worked in Chrome as well. So let's look at some more modern techniques, and fetch is the most obvious thing to use. One of the patterns of the fetch method is a URL and a fetch options object. And the fetch options object defines a number of properties which can control the fetch, one of which is cache. If you set it to reload, then it will cause the fetch to skip the cache. But what you receive in the response can then be saved into the cache. So it's perfect. It's exactly what we want. So I tested this. Wrote a little bit of code that waited on a fetch with the cache configuration parameter set to reload, and didn't do very well. So the problem here is that Safari has a split cache. It caches responses from the fetch API separately to navigations. So resources that we load when we navigate from one page to another are actually not purged when you do a fetch from JavaScript, which is very annoying. In Firefox, that behavior is only true for foreign origin resources and not for same origin resources. Although that behavior can change depending on your cause configuration and whether you include credentials in your request. So this is an illustration of the problem here. You essentially have multiple caches within the browser. Browsers actually have loads of caches in them, and which one it chooses to use is actually quite complicated. In Firefox, it will switch between the fetch cache and the navigation cache, depending on what the initiator of the navigation was. So I thought, okay, let's try something else. I quite like the vary header. Some of you may have seen me speaking about vary in the past. I thought I can use vary to solve this problem. So I could, instead of setting cache reload, I could set a request header to send an additional request header, force reload, and set it to some value. And if the server is configured to always return vary force reload, regardless of whether there's a force reload header in the request, then we can use that request header to ensure that we get a cache miss in the browser. And combined with the fact that browsers will only store one variation of any varied object, this means that when we do our fetch, we will skip the cache, and the response will then get saved into the cache as an object with a cache key that includes the force reload header. That means that it also won't be valid for any subsequent navigation, because subsequent navigations will not include the force reload one header. So we'll have to load this object twice in order to get through our full reload of the object into the cache. So it's not super efficient. It also still doesn't work in Firefox because we're still hitting the problem of splitting the cache between fetches and navigations. So I thought, okay, fine. What about posts? Because according to the HTTP spec, post is an unsafe method, and unsafe methods should force the user agent to discard any object that has been previously cached against that URL if they receive a successful response status for a request for that URL on an unsafe method. So essentially, if you make a post to a URL and the server responds with a 200, then if the browser has a cached copy of that response, it should evict it. So does that work? We can test this with making a fetch, just swap the configuration again just to change the method to post. And can we force it out of the cache? No. Again, the problem is that Safari and Firefox are suffering from this problem of having split caches between fetches and navigations. So like, okay, fine, we can't use fetch, so we need to use some kind of method that is going to cause a navigation load rather than a fetch load. So what if we created an actual HTML form and put it in an iframe and submit it using JavaScript? So that's this. So we create an iframe, append it to the document, create a form within the iframe, set the target of the form to be the object that we want to evict from the cache, and submit the form. And this works perfectly in all browsers. It has some unfortunate side effects, which is that Firefox doesn't clear the fetch cache for cross-origin resources. That's probably okay, because probably the thing that you want to evict from the cache is in the navigation cache rather than the fetch cache. So I considered that to be probably fine. It does require 2 fetches, because the first one, the post, is not actually going to get cached. So you'll then need to make a subsequent GET request in order to repopulate the cache. And it also creates a browser history entry, which is kind of annoying. But all of these things are still better than the location reload true solution. So that brings us to our final solution of clear site data. So clear site data is the simplest and most elegant solution to this problem. If you have a resource that you're simply not receiving requests for because all the requests are being satisfied by the local cache, but you are receiving requests for something on the same origin, then you can just respond to any of those requests with clear site data cache, and that will actually toast your entire cache for the whole origin. So any resource, whether it's a page or a sub-resource or a fetch response that is associated with your origin, will be deleted. There's actually a number of different tokens you can pass in the clear site data header. Cache is one of them. You can also clear storage, cookies, and execution contexts, which would kill your service workers. So This is working today in Chrome, which is actually already better than when I first did this research, when it worked in no browsers at all. And it is being actively implemented by the others. So as and when this arrives, this will be a good solution to this problem, albeit a very blunt instrument. So for the moment, the winner is posted in an iframe in concert with other techniques. If there's a more elegant technique available for certain browsers, then you can obviously combine them together. Another solution is you could just use a different kind of cache. So if you were to get rid of the HTTP cache and return all responses from your server with a cache control header preventing the response from being cached at all, then you could create your own cache layer and a service worker using the caches API. And this is remarkably straightforward and offers a complete JavaScript API, allowing you to add and remove items selectively. The API is asynchronous. It provides its promise-based, and it's really easy to understand and to use. So this is great if you're willing to roll your own cache layer. So we talked about number one, how we're going to evict an item from the cache, and Harry, you've got a notification from Papa John's about your pizza delivery. It was an email. So that's the first thing, and then the second thing. The second thing was, how are we going to tell the browser that an eviction is needed? So this is a little bit less interesting because there's really only one technology we can choose from to make this work, and that is the Web Push API. And the Web Push API is responsible, as I'm sure you know, for all of the incredibly annoying pop-ups that we now get asking us to allow websites that we have literally visited for 3 seconds so far to send us notifications forevermore, to which I always press block immediately and then think, actually, did I want that or not? So the Web Push API is a channel. It really doesn't have an opinion about what you use it for, but it's a way to send messages asynchronously to a browser from an origin that may not currently be open in an active browser tab. Now, when you ask for permission to use the Push API, it typically prompts the user with an explanation that the website wants to send you notifications, because those two activities are very tightly bound together currently. But the Push API doesn't necessarily have to result in a visible notification being displayed to the user. And ideally, we would like to see something like this, where an event occurs on the server and we can send a purge request to edge caches, and we can also send a silent web push notification to end users that have that object cached to tell those browsers to evict that object. So today this doesn't work because browsers quite reasonably have the opinion that websites should not be able to just randomly use compute resources in the background when your website is not open. So if you send a notification via a web push to a browser that then does some work in a service worker and doesn't display a visual notification to the user, then Chrome will do it for you, and it will say this site has been updated in the background, and Firefox will simply cancel your subscription so you don't get any notifications ever again. So they're pretty draconian about this, and quite serious about stopping websites from abusing the ability to do background work. And I think that's probably a good thing. But obviously, this is a valid use case, right? You know, there is a good user benefit to being able to do this kind of thing. So there was some effort put into this, and there was a spec created called the Web Budget API. And the purpose of this was to give you a queryable API that would tell you what your quota was for doing this kind of work. So you could say, am I able to, if I sent a silent push, would it work? And the API would tell you whether it would work or not. And this would be based on things like heuristics of the user's level of engagement with the site. So if I've just arrived on a site that I've never visited before, and this site decides that it wants to start sending silent push notifications in the background and doing work, then the browser could quite reasonably say, no, you can't do that. But if it's a site I engage with regularly, then maybe I can do quite a bit of work in the background. So this unfortunately hasn't really gone anywhere. The latest that I saw was Mozilla evaluating it a couple of months ago and saying that they felt that Google was giving up on it. So hopefully there will be some other method of doing this, because there's nothing that inherently ties the push API to displaying visual notifications, and the ability to do other things is obviously useful. We just need to make sure that it's not misused. So in summary, turns out clearing the browser cache is quite hard, and the proper solutions are clear site data and cache reload as part of the fetch API. Where those don't work, the most effective currently today is to post in an iframe if you want to use the HTTP cache. Alternatively, if you don't need to use the HTTP cache and you're willing to roll your own, then the Service Worker Cache API offers a very straightforward way of directly managing in a very granular way the items that are in your cache. And WebPush gives you a very effective way of proactively notifying browsers that they need to do some cache management. But currently, you will need to display a visual notification to the user that you've received it. So it's not the sort of thing you want to do every few minutes, but maybe when a significant amount of content has changed. And that's all I have. Thank you very much. So just before we do questions, I'm required by our marketing team to plug our upcoming conference, Altitude, which is next week, is it? No, 2 weeks. It's going to be great. We have Kate from the FT doing a talk, and a number of other industry luminaries, and lots of interesting content about performance. So if you're interested, please do come along. It's free.
Okay, we're going to have a bit of running around with the mic. So, got questions. So if you can sort of like half come to me. So Andy was first, then I'll come to you later. Yeah.
So do you have any idea what the rationale between splitting navigation cache and the fetch cache is?
I think it's mostly an effort to follow the rules on cores, which are really complicated. And so all my examples are including credentials in an attempt to try to get around that problem, because when you do a navigation, you obviously include credentials. There's no way not to. So when I was using fetch, I was including credentials to try to avoid a kind of early fork into a separate cache. But you know, there are other bits of logic in there that mean that fetches often end up in a different bucket to navigations. Another thing I will just mention in a similar kind of vein is that Safari double keys any third-party stuff. So if you load a foreign origin content on your website, then like jQuery or Google Analytics or something like that, then you can't access the same cache that some other website is using when they load exactly the same URL, because Safari will use your origin and the origin of the object that you're loading as part of the cache key. So you won't be able to access the same cache object. So there's lots of that kind of logic going on that makes it sometimes quite difficult to hit the object in the cache that you want.
I'll come back. There's someone down here first. I'll come back.
My question was almost exactly the same as the last one, but I'll ask it anyway. Is that way of having the two different separate caches, is that like totally compliant with like the fetch spec, and is that just the way it's going to be like forever in Safari, or are they going to like make? Because that just sounds like such a much easier way of doing things rather than like all that crazy stuff with the service worker. Because you know you said doing the service worker and your own cache is like easy peasy. It's not like that easy. It's a fair bit of work.
Okay, so I feel like I should say I didn't say it was easy. I said it was straightforward. So, so the API is straightforward. Like, it's easy to understand, but I completely accept it's a little bit like implementing scrolling. You know, in principle, it sounds like a really easy thing to do, and in practice, you realize like the number of affordances and you know, minute details that are part of the OS's implementation of scrolling is far more than you're ever going to be able to put the effort into creating yourself. So, you know, caching, I feel like is one of those things where it's very easy to make the decision to roll your own cache layer, and then it's also very easy to regret that later on. In terms of whether they're spec compliant, that's not something I feel like I talk about authoritatively, but my feeling is that just deciding to have multiple caches is not like a spec violation. I'm looking at Patrick now. Do you know the answer to this? Okay. Let's say it's fine. Well, it's not convenient for developers, but I think from an implementer perspective, there's obviously a lot of convenience that you can get from you know, just ferreting things away in different places, different bits of memory, rather than trying to achieve the elegance of, you know, everything converging on one single shared cache, especially when you've got to evaluate all the cause rules and everything, which you would have to throw into the same cache key, and it would be complicated. So some do that. Chrome has a pretty consistent shared cache for everything, but Safari has the most fragmented cache that I've discovered.
Yeah, I'll just give a shout out to Yoav's blog post about that as well. So Yoav Weiss of Akamai wrote a very good blog post called "The Tale of Four Caches" in the Perf calendar last year, I believe 2017, and he details specifically why the fetch cache exists, if you want to know more.
So the way we beam lead him to avoid the cache is we just add a revision file number to the end of it. Would you not advise you to do that? Okay.
The answer was, of course, if you can.
Yeah, if you can rev the files, then yes, obviously that's a better solution. You know, consider the files to be immutable, and then just change the URL. This entire talk is sort of based on the premise that you can't do that, which is because, you know, you have a product URL or a, you know, homepage or an article page URL that can't change because you're linking to it and you're sharing it and all that kind of thing. So yeah, obviously for script files and style sheets and that kind of thing, but then third parties like, you know, your Google Analytics of the world can't distribute a new revved URL to everyone. So that's the kind of area where these techniques would be needed.
Like use your CDN to like in front of all these third parties.
Well, so there's a pattern that's quite common for third-party scripts called the Scout pattern, where you have the URL that you ask your customers to embed in their site is actually a very, very small resource whose only job is to write a revved script tag, so that you can then change it in the very short-lived Scout response. But then you have a very long-lived main script file. But you know, there's some cost to that. There's indirection. There's an extra request. So you know, you just have to evaluate the solution that works for you.
Any more? Yeah.
So in the note about the web budget API, it mentions that Google thinks there are simpler approaches to determining the relationship between user engagement level and amount of resources that the service worker is allowed to consume. But what do you think, if you're a browser vendor, how would you be solving that problem, which is obviously is a problem at the moment?
So the Mozilla review is actually really detailed. It's written by Martin Thompson, who is one of their sort of key open source spec people, and he postulated a number of solutions. So I'm not being original about this at all. I'll just sort of parrot what he said. But his concern with the budget API as designed was that it was a little bit too complicated. You had to request budget for something, and then you would either be given it or denied it. So he thought that he could foresee developers using this by just continuously requesting budget in a loop until they were rejected, and then they would know exactly how much they had. And he wrote sort of pseudocode to say, like, I can see people doing this, and I was thinking, yes, I'd probably do that. So I think it's a very good, astute observation. And he suggested that there just be a property that you could read that says this is how many pushes that you have left, and that would just be a much simpler way of exposing the data. It would probably be per origin, yes, and it would probably only exist if you had a service worker and notification permission, that kind of thing. And also the number would be assessed based on your engagement score with the website or whatever. Yes, so this would be an area where implementers could try and, you know, compete on in terms of, you know, finding the right balance so that, you know, they were providing a good user experience without being annoying, all that kind of thing. So I don't know what the right solution is, and no one seems to be actively working on a solution at the moment.
Any more?
I'm just brainstorming here, but could you actually use HTTP2 server push for it to send a new resource to it? And maybe it's actually also related to the caching issues that that in itself has as well, to tell the server it needs to send something new.
We had a university challenge nominate go on there. So Andrew nominates Patrick.
Yes, you could definitely use the push frame to do that. Like, the push frame is not spec'd designed to do that specifically. The reason why I'm hesitant and about talking about this in general is that we don't even know the state of push at the moment. There was an IETF meeting in London last month that was discussed that it may even be ripped out of the HTTP2 specification. Unshipped, as Andy Davis has just said. However, I had a very interesting conversation with Patrick McManus, who is the principal developer of networking from Mozilla for Firefox specifically, and he believes that push should still exist, not necessarily designed for pushing resource hints, which was designed to do to the browser things that you may not have in your cache. But obviously the problem with push in general for its primary purpose is that you may be wasting bandwidth. Like, you don't know what the user has in their HTTP cache. And so specifications such as Cache Digest were built to overcome these problems. So a way of because HTTP is stateless, we don't know the state on the connection. So we could create something like Cache Digest that allows the client to report its state to the browser via a different HTTP2 frame. But there has since been better specifications such as the 103 early hints status code to do this. But going back to your question, sorry, Patrick McManus believes that yes, push should still exist to be able to do bidirectional communication between that, or unidirectional rather, from the server to client. And that use case is an interesting example. However, sadly, it's definitely looking like that's not going to be the case. But I do admire your thought process to come to that. But push is inherently flawed, unfortunately.
Yeah, it was exactly what I was going to say, that you might be hearing something more about that in the next talk.
And also, can I just add to that, that in order for that to work, you would need an open connection, right, Patrick? So you know, if you want to push an eviction to a browser that doesn't currently have your website open, then you know you're basically out of luck if you want to use an H2 connection. If the site is open in an active tab, then you know you actually have lots of other options. You could use server sent events, for example, You know, you could even poll. It's the fact that the site is not necessarily open, and you have to send that notification to the service worker that makes web push basically your only option.
And your point is that the web push API exists for that.
Yes,
purpose.
exactly.
So is the question, like, I think it's a good ethical question, rather than using HTTP push, why not use the push API and instead of talk? But then there's ethics around that of actually you are forcing the background without asking them. But maybe this is a good use case for that. I'd be interested in knowing what people think of whether or not. Would you like your device doing background things, the website sending you stuff about you? Yeah.
Well, and also just as a sort of random thought on this, I think the browser would be quite well advised to delay that processing until you are about to view the website again, right? Because there's virtually no benefit to immediately doing that processing. It could defer that processing and do it like you're just about to. It's like a render loop, basically. You've done a whole load of rendering, and now we need to repaint. The same could be true of doing background processing in theory.
So think about what all those native apps are. The web is very pure.
Yeah. Yeah, native apps can do anything at any time. So, you know, it's to some extent. Cool. I think we're done then. Perry's disappeared. So, you know, we're basically on our own at this point. Who's got booze? Anyone got any more questions? Simon? Oh, you've got booze. Okay, that's good. Carry on. Okay, well, in that case, I'll just talk about Altitude. You should all come to Altitude. It's great. Registration's open now. No, seriously, it's great. I think I'm going to put the mic down now. So thanks very much. Compare it to Mozfest. I have never been to Mozfest, actually. I'd really love to go to Mozfest, but I don't know. No, I can't win. Okay, thanks very much.